Welcome back. So today we're going to be working with radicals. So there are three parts to this radicals unit. So part one is what we're going to be working with today, and that's going to be simplifying radicals and adding and subtracting radicals. So you'll need your worksheet, radicals worksheet number one, and we're going to be going through some of those examples on the notes today, and then you'll have a few of them that you're still doing on your own. So number one here, so this is actually number one on your worksheet. So it's the square root of 196. So when you're doing square root of 196, you can actually do this a couple of different ways. You will have a scientific calculator for things, so obviously you can use your scientific calculator and plug in square root of 196 and see what it comes out to be. The other way that we can do this is by figuring out what are the factors of 196. So that's the way I'm actually going to show you. So 196, I know 2 will go into there. I believe 4 will also go into there. So we'll just check and see. So 4 goes into there. So that's going to be 49 times. Okay. So then when I'm looking at those two numbers, something to keep in mind is we're always looking for perfect squares. 4 and 49 are both perfect squares. So 4, so if we take the square root of 4 and the square root of 49, the square root of 4 is 2. The square root of 49 is 7. 2 times 2 gives us 4. 7 times 7 is 49. And so then we can say that the square root of 196 is going to be 14. Now, I didn't know that off the top of my head. There's some of them that I do have memorized. That's not one of them that I have memorized. And so I'm assuming you guys probably don't either. So that's why we went ahead and used this one as an example. So 196 is a perfect square. It goes in there evenly 14 times. But in order to break that down so that we can simplify it, this is one of the strategies that we're going to be using throughout this lesson. Okay, so let's go on to number 6. Number 6 is not a perfect square, and it has some variables in it. So adds a couple different pieces there. So the first part is we're going to be dealing with breaking these different things down and looking again, like I said, for those perfect squares. So in order to do that, I'm going to look at the 98 first. 98 is an even number, so I know 2 is going to go into that. So 2, and then half of 98 would be 49 again. I know that 49 is a perfect square. So we're going to say square root of 2, square root of 49, and we're going to keep simplifying here. So we have x to the 11th power. Okay, well, like I said, we need things to be perfect squares. So in order for it to be a perfect square, it needs to be divisible by 2. So we're going to break this down to square root of x to the 10th, because that is divisible by 2. And then a square root of an x. So 10, one more gives us to the 11th power, which is what we had over here. So we're just breaking these things apart. We're going to do the same thing with y. So we're going to go y to the 6th, since that's our even number. And then we've got 1 left over. So now we've broken everything apart, and so that we have some perfect squares here. So we're going to come back and look at these, and anything that's a perfect square, we're going to go ahead and simplify. So 49 becomes 7. X to the 10th. So since this is square rooting, we're going to divide that exponent by 2. This becomes x to the 5th. Over here we have y to the 6th. Again, we're going to divide that exponent by 2 because this is square root. So this becomes y to the 3rd. These other numbers are still underneath the radical because they are not perfect squares. So we'll just go ahead and bring those down. And then we're going to reorganize things. So everything that's outside of the square root, we're going to put in the front. Everything that's under the square root, we're going to put in the back. So we're going to go 7, x to the 5th, y to the 3rd. And then we have our square root symbol. We have a 2, an x, and a y. Okay, and so that's how we simplify those. Let's go ahead and look at this next example, because sometimes we're not going to be dealing with square roots, but we're going to be dealing with third roots. So this time it looks a little bit different. So we have 24 here. So again, I'm just going to break this down. I know that 24, I'm going to have 6 and 4 would give me 24. 6 breaks down to 2 and 3. 4 breaks down to 2 and 2. So now I'm looking for threes of things. So I have 1, 2, 3 2s. So I can say that this is 2 to the third power times 3. And then we're going to do similar here with our exponents. We want these to be in multiples of 3 though. So this is to the third root here. We're going to go x to the 12th. So 12 is divisible by 3 and we have 1 left over. The next one is a 4. So we're going to go y to the third and we have 1 left over. So 12 and 1 gives us the 13. 3 and 1 gives us the 4. So again, just like we did on this earlier one, now we're going to go through and do the third roots. Sorry, let me put my little 3s there. The third roots of everything. So the third root of 2 to the third power is going to be 2. The third root of 3, we don't have one, so we're going to leave that one the way it is. The third root of x to the 12th, this is going to be x to the 4th. 12 divided by 3 is 4. This next one's just going to stay the same because it doesn't have a third root. Y to the third, 3 divided by 3 is 1, so this is just going to become y outside of the radical. And then we're going to leave this last y underneath the radical. So again, just like we did before, everything that was outside of our radical, we're going to put those together at the front. So 2x to the 4th, y. And then we're going to go to the third root. We have a 3, an x, and a y. So that's simplifying those radicals, whether you have a square root or a third root. Okay? All right, so the next thing that we're going to do is we are going to be adding radicals. So in order to add radicals, you have to have the same number underneath the radical symbol, and it has to be the same radical. So if it's a square root, they all have to be square roots. They have to be the same square root. So for example, this first one that we have, this is number 11 on your worksheet. Since this is 6 square root of 15 and 3 square root of 15, they both have the same radical. We're just going to add them together, like as if those radicals were x's. So this is going to be 6 plus 3, which is 9, and then our radical is 15. So it's going to be 9 square root of 15 would be our final answer. Okay, so the square root piece did not change. It was just the number that's out in front. Okay. All right, so now we're going to look at this next one. So if you look at number 14, our numbers aren't all the same. Okay, so I actually want to try to make them the same if at all possible. If not, they would just stay separated, so we actually wouldn't be able to combine these if we couldn't break them down to be the same number. But for this one, I'm going to take my 6 square root of 5 plus 2. Now I'm going to look at the 45 and say, okay, does 5 go into 45? Because I have a 5 here. So this would be square root of 5, square root of 9. 5 times 9 gives me the 45. Plus 3 times, I'm going to do the exact same thing here. I'm going to say, okay, 5 times what gives me 125? So for this one, it actually ends up being 25. So we're going to put 25 there. Okay, and now we're going to go back and we're going to simplify anything that we can. So I've got 6 square root of 5, that can't be simplified. 2 parentheses, the 5 is not a perfect square, but the 9 is. Square root of 9 is 3, so this becomes 3 square root of 5. Plus, again, looking at our parentheses here, we've got a square root of 5, a square root of 25. 5 is not a perfect square, but 25 is. So I'm going to go ahead and square root that. That becomes 5 square root of 5. Okay, we're going to continue to combine things that we can. So 6 square root of 5 plus 2 times 3, because this is multiply right here. That's 6 square root of 5 plus 3 times the 5. 3 times 5 is 15. And that's still square root of 5. Now I have all of them, just like I had up here, they all have the same radical, square root of 5. So I can combine all of those. So we're going to take 6 plus 6 plus 15, which gives us 27. So this becomes 27 square root of 5. Okay. All right, so we're going to do some subtraction ones. Subtraction is very similar, but I have some different examples here that will help you in some other scenarios. So remember, subtraction, you can apply these same rules to your addition stuff as well. All right, so subtraction. So again, first thing we want to do is look at them and simplify as much as we can. 100 is a perfect square. What times what will give us 100? Well, that's going to be 10. And then if you remember, I said some of these I do have memorized, some of them not so much. 256 is one of those that we use an awful lot. The square root of 256, in case you don't know. I'm just going to pull out my calculator here so you can kind of see what I'm doing. I'm going to hit the square root button. Helps if I turn it on. Try that again. The square root button, and then I'm going to type in 256 and hit enter. And it tells me the square root of 256 is 16. Okay, so that's how you're doing those with the calculator. Like I said, sometimes your calculator will simplify radicals for you if you're lucky enough to have one of those. If not, you can always use the factors that I was showing you. So now we just have 10 minus 16. 10 minus 16, super easy subtraction problem. We get a negative 6. And that's your final answer. All right, the last example that I have for you is number 19 from your worksheet. So we have 3 square root of 8 minus 7 square root of 32. Again, these do not have the same radicals, so we are going to break them down and see if we can get them to look the same. Okay? All right, so on here, we're going to go 3, and then 8 I can break down to square root of 2, square root of 4, minus 7. 32 we can break down to square root of 16, square root of 2. Okay, and then I have some perfect squares there. 4 and 16 are both perfect squares. So I've got 3, square root of 4 is 2, square root of 2. 7 square root of 16 is going to be 4, and then we still have the square root of 2. So again, just like we were doing on one of the other problems, 3 times 2 is 6. 7 times 4 gives us 28. Now we have the same square roots, so we're going to take 6 minus the 28, which gives us a negative 22, and the square root of 2. All right, so just in case you have one of these, I didn't actually end up pulling one that was an example of this, but in case you had something that, let's say it was 6 square root of 3 plus 4 square root of, let's say 12. Okay, so we can break down the 4 square root of 12. So 4 square root of 4 square root of 3. Oh, that's not a good example either. Let's try a different one. Let's do 6 square root of 3 plus 4 square root of, let's just say 5. So these aren't the same. Since these radicals aren't the same, you would have to leave this like this. You can't combine this anymore. So you would just, this would be your final answer since we can't simplify it. So that would be an example where you would have two separate terms. But I believe most of them on your practice problems, at least at this point, should all be simplified to the point where you would have the same radicals like square roots of 2, square roots of 5, square roots of 15, things like that. If you have any questions on your practice problems, you do have numbers 1 through 20. This is worksheet 1. And we did several of them together. If you have questions, please let me know. Otherwise, I will see you in class. Have a great day. Bye.